Thank you. Well, first, I'd like to thank Marco Panza for the invitation. It's really a pleasure to be here speaking to you all. Any excuse to come back to beautiful California, I always take. It's very, very nice. And so this is part of, as Marco said, sort of an empiricist project, right? Of trying to defend a form of empiricism in logic and mathematics that hopefully it's a little more plausible and defensible than the versions that you find, from Mill, and Carnap and others. So this is one piece, right, of the puzzle, and I'm going to engage with the very idea of logical necessity and whether there are any grounds for things, right? Now, logical laws typically are conceived as being necessary. That's a sort of the traditional view of the subject matter. And the question is, in virtue of what this is the case, right? What are those grounds for logical necessity? So I'm going to consider four different answers for this question, right? In terms of truth conditions, invariance of truth values under different interpretations, possible worlds, or brute facts. And what I'm going to argue is that none of them, I think, ultimately work. And then what I'm going to suggest is, in face with those difficulties, that a view of logic that completely dispenses with those grounds for logical necessity would be at least a less problematic alternative, right? And then I'll suggest, what this view would look like, right? And it will be, as will become clear, a form of empiricism, and we'll see how that works, right? Now, being an empiricist means being a skeptic at least 3 times a week, right? And it turns out that on Mondays, Wednesdays, and Fridays, I'm a skeptic. Well, it's very good. So it happens that that's the date on which I'm giving this talk. So I'm going to start giving you actually, it's a very general argument to the raise of a certain kind of skepticism about the very idea of those grounds of logical necessity. And as will become clear, the specific 4 answers that I'm going to give are particular versions of these arguments, right? And they'll show up in different ways, right? So here's the way it goes, right? Can there be grounds for logical necessity, right? Can there be something that explains in virtue of what that necessity obtains, right? Now, let's assume that there are those grounds, right? And then the question is, are these grounds themselves necessary or are they contingent? Well, the grounds cannot be contingent, since the explanation of something necessary based on something contingent will be inadequate, right? After all, the contingency of the grounds would fail to support the necessity of what they ground. So that's a non-starter. On the other hand, the grounds cannot be necessary either, since if the grounds were necessary, an explanation would then be needed for their necessity. And any necessity that is simply assumed as understood will be ultimately not explained. So that doesn't work either, right? Beautiful, deductively valid argument that challenges the very idea of those grounds, right? So in the end, it's unclear that there are grounds of logical necessity, right? Now,
even that could be the ground.
That's right, even even stronger, right? So, and in more general, I think it's unclear that there is a satisfactory answer to this question about these grounds, right? And this is a version of a consideration that Barry Stroud raised, many years ago, and I explored some aspects of that in a recent paper, doing something, pushing the boundary on the idea of logical aliens. That's something that also Stroud conceived, right? But what I'm going to do in today's talk is use this as a general framework and then look at specific cases, attempt to justify those grounds and see how these general considerations would actually play out in particular contexts, right? So as will become clear, I think logical laws are better thought of as actually being contingent rather than necessary, fallible rather than infallible, and domain dependent rather than topic neutral. Right? So that's the picture that I'm going to eventually suggest as we go through the various options. And of course, once you have that picture, the need for necessary grounds will completely vanish. Okay, so let's consider the four possible answers for those grounds, right? Now consider specific logical truths, right? So the first answer, the necessity of logical laws, is grounded on the truth conditions associated with logical constants, right? So given the truth conditions associated with the constants, logical laws must be true, right? The necessity results from these truth conditions, right? Consider, for example, the case of conjunction, right? Here we're assuming classical logic, right? So the conjunction of A and B is true, provided that A is true and so is B, right? And as we know, it follows from the law of conjunction that from this, we're introducing conjunction, that the law of conjunction elimination must be true, right? And the reason for that is simple, right? Given that the truth of A and B on pain of inconsistency, A must be true, right? And of course, similar considerations would offer the necessity of other logical laws, given the truth conditions associated with the logical constants in questions, right? So far, so good. We say, well, that's how we get those necessities, right? Well, I think there are a few problems, right? I'm going to highlight two. One of them, the account assumes the necessity of the truth conditions associated with conjunction, right? So in a way, it's not only that A is true, provided that the conjunction is true, provided either of the conjuncts is true, right? Because what you need is actually the necessity of these conjunction formulation. Because if you're just a contingent fact that a conjunction is true, provided that its conjuncts are true, the necessity of the law of conjunction elimination will be grounded on something contingent. And we saw that is a non-starter. Because this in turn would entail that had the conjunction introduction or conjunction formulation being false, which is a genuine possibility given its contingency, the law of conjunction elimination could be false as well. Right? But if conjunction elimination could be false, it would not be necessary. Right? It's possible that its negation hold, and then it's not necessary anymore. So what you need is not just the conjunction, the law of conjunction for the formulation of conjunction, right? What you need is necessitation of that. Right? But then you assume the necessity, right, to justify itself. Then we're back to the difficulty. Okay, so that's one concern. The other concern is that it's actually not even clear that the law of conjunction elimination is necessary in any case, right? Since I think there are some contexts in which it's violated, right? Consider the following one, right? You may not believe, but there was a time, a long time ago, in which I had hair, right? So I tell my students, yes, I did have, right? So in fact, I used to have, at that time I played guitar in a jazz band, had a long hair, so good old days. I tell my students, here's one piece of advice, don't get old. They don't hear, please, right? Okay, so, but in those days, right? So consider the following situation, right? Now I'm bald, right? Now he's bald now, right? So, because I decided that I'm no longer a vague object, right? I'm definitely bald, right? And but I could have done something different. Bald, and instead of shaving my hair off, I actually went to a hair implant, right? So therefore, I'm bald, right? And you say, well, wait a minute, right? This seems to would undermine conjunction elimination, because if I had a hair implant, I cannot be bald. That's the conclusion statement, right? Of course, you may say, but wait a minute, there's a temporal difference between these two premises, right? In the premise, I was bald. After the hair implant, in the conclusion, I'm no longer. So there is this variation, right? So there is an ambiguity. The problem is in classical propositional logic, there is no such a thing, right? There is no room to accommodate that. I'm just taking classical propositional logic in its own terms, right? So I'm bald, true. I receive a hair implant, true. Therefore, I'm bald, false, right? So that's the idea, right? Now, of course, classical logicians would do all kinds of things, all maneuvering to avoid those things.
The
right?
premise is false. The premise of this argument.
Well, it's not, right? It's only false afterwards.
No,
but-
it's false. If he is bald and has received, then
Well, okay, but then you're considering now the conjunction of two temporally disjoint events, right? So look, classical logic doesn't have the resources to do that, right? At least not the propositional one. If you want to quantify over time instant,
But
you might be able to do, but then it's a different argument.
yeah, I went to the discussion because you said that we
Okay.
do that.
Yeah, we can talk, yeah.
But either you accept that we can express the past of receive classical logic and then this is false, or we cannot express the past and then you cannot say that. But
We'll see.
discuss it.
Okay, we'll see how it goes.
You know, the Macaulay learn from me very. I tried.
That's right, you're right, Marco.
Sorry.
All right, we'll talk, right? Look, my point here is, we can discuss, right, those things. Is this a genuine counterexample or not, right? So I think it is really. Classical logicians may complain, right? My point is, that it's not obvious to me that the law of conjunction elimination is valid in every context. I'm giving an illustration, right? Context in which there are temporal shifts. I think a context in which, classical propositional logic has not been devised to deal with, right? That's the only thing I actually be pushing here, right? We can come up with a different example if you want, right? Okay. So in that case, okay, you may have worries that conjunction elimination, even goes through, right? I actually think we can raise similar concerns to other, in fact, every other principle of classical logic. There are contexts in which they fail. But I'm going to give other examples for other laws as we go along, right? And of course, if they fail in some contexts, they're not necessary. So the idea of even looking for grounds for their necessity is uncalled for. Okay, that's one option, right? Second attempt to ground logical necessity, invariance, right? The necessity of logical laws is grounded on the invariance of the truth values of these laws and the different interpretations of or different semantic assignments to the non-logical vocabulary. Right? So in every interpretation of A on A necessarily comes out true, right? Given that the truth of the disjunction depends on the truth of at least one of its disjuncts, right? So familiar argument, consider interpretation of A, right? So if A is true, so is the excluded in the middle. If A is not true, then the negation of it is true, and then so is excluded in the middle. So if any of those assignments of truth value, the excluded in the middle goes through. So A or A is necessarily true, since it holds in all possible interpretations. So it looks like, okay, now we have the modality here, that's what grounds, then the necessity of excluded middle, right? Now, I think also there are problems here, right? Now, again, the account assumes the necessity of the assignments of truth values to the statement A, right? In the sense that all possible assignments, in all possible assignments, the truth of the logical law results, right? In particular, it's assumed that necessarily either A is true or its negations. But these are the only two possible assignments, right? After all, if this were not the case, and A lacked the truth value, the excluded middle would be arguably indeterminate. And the whole thing would not go through. So there would be no grounds in that case for the assignment of truth value to it, right? But this then entails that the necessity of excluded middle is then grounded on the necessity of bivalence, right? And it's unclear that bivalence is necessary. Right? Why? Well, here's an example, right? And I think the same worry will go for excluded middle. Both of them are trouble in contexts like this, right? Consider a statement like the number of hairs in Anna Karenina's head is even, right? Now, arguably, despite the size of Tolstoy's novel, nothing is said about it, right? That's very important.
You did not read the page of 430.
I checked, right? It's not in the novel, nor in anything that follows logically from all the things that are said in the novel, right? And I'm dying to know this, right? It's a very important aspect of the novel, right? So if there's nothing there that satisfies the man, right? To insist that there is a definite truth value, but we just do not know what it is, seems completely unmotivated, right? After all, fictional characters as opposed to real people are incomplete objects, right? That's a point that, for example, that makes beautifully with object theory, right? And I think that's an interesting and important insight, right? And so unless something is explicitly stated in the relevant fictional work, or unless it follows from what is so stated, the result issue is just left open. Right? For nothing else could possibly settle the matter one way or another, right? You know, if Anna Karenina was a real person, well, then there would be a certain number, right? We may not know what it is unless we count, but then there'll be a fact of the matter. Not here, right? In the case of a fictional object. So the statement regarding the number of hairs of Anna Karenina's head lacks truth value, right? So bivalence is violated. Okay. I think that's a general feature of fictional context. And I think the precisely the same considerations apply to vague contexts as well, right? Of course, you know, Timothy Williamson goes at a long length to try to preserve bivalence and excluded middle, even in the presence of vagueness, right? You need to be an epistemicist about that. So yeah, there is a fact of the matter, we just don't know what it is, right? Not clear that that is very plausible in the case of Anna Karenina. In any case, I don't think it's even plausible in other contexts as well. What's interesting is you need a book-length defense of something that it seems more plausible to say, look, classical logic just not equipped to deal with that. It's violated in case of vague objects. So it's not designed to do these things, right? So no grounds there. Third option. Possible worlds, right? We may say the necessity of logical laws is grounded on the fact that they hold in all possible worlds. So in every possible world, nothing's both A and not A. Hence, the law of non-contradiction holds in every world. It's thus necessarily true. Even that, however, I think is problematic. First, the necessity of the law of non-contradiction depends on the necessity of possible worlds, in the sense that in the logical space containing all worlds, all possibilities need to be contemplated. It's unclear, however, what grounds the fact that in no world A and not A holds. Why is that? Right? Or it could be argued that, well, A and not A is an impossibility, and hence it's nowhere to be found among possible worlds. Right? After all, only what's possible is part of the world. So that's why you don't find in the logical space of worlds is exhibiting that feature, right? But this assumes an understanding of modality that it's not available to a realist or a reductionist, right, about modality, right? Such as, for example, David Lewis. Right? The claim that A and not A is an impossibility that no world can exist assumes an understanding of possibility that is independent of worlds. Because now I'm talking about what's possible in a world, right? And modal realism reduces possibility to worlds. So I cannot apply modality to worlds. So this is out of scope, goes beyond what's possible to be expressed according to the modal realist, right? I think that's an artifact of the reductionist strategy that modal realism invokes, right? It doesn't have the resources to ask a question that we can do perfectly well in English. And say, is this possible in a world, right? Why is this in no world this is possible, right? And that's an expressive limitation that modal realism has, despite all the arguments that Lewis raised against what he calls Ersatz modal realism, right? If you think about world as concrete, as abstract objects, you cannot express all possibilities, but you can if worlds are concrete, maximally extended spatial temporal objects, right? There are limitations in what you can express modally if you are reductionist about worlds. Right? So reductionist possible world theories is enable them to recognize possibilities about worlds. Possibilities are to be expressed in terms of worlds. They cannot be applied to them. That's part of the limitation of the frame. Note that a weaker claim to the effect that A and not A is an impossibility that no world does exist, rather than no world can exhibit, is not enough to secure the grounds of the necessity of the negation of law of non-contradiction, right? If it's possible that in some world A and not A is true, then the necessity of the law of non-contradiction is questioned. in those worlds, it will actually fail. So you need actually a model version, right, of the claim, not just that no world exhibits, right? What you need is no world can exhibit the contradiction. Because otherwise, the law of non-contradiction would not be necessary, would be violated in some way. As it turns out, I think it's part of the structure of the logical space, the space of all possible worlds, according to the realist, that the modal realist assumes that no impossibility can be exhibited. So there is a primitive modality, despite everything that Lewis was trying to do, right? That's an example of the kind of primitive modality that I think modalists, Scott Charkowski, suggest. So we need a primitive modality in any case. So the idea that we could reduce it to some non-modal option doesn't go through, right? However, what's possible to hold in a possible world is not a concept expressive in standard versions of modal realism, right? Now, John Divers, introduced what he called advanced modalizing as a way of trying to fix that problem, right? And what he does is to treat modal modifiers as being semantically redundant in some instances. When we're talking about what's possible in a world, you would have to say, well, then it's true there is a world in which, in this world, this thing holds. So you have to iterate worlds, right? And so, well, then the worlds are just semantically redundant. Get rid of one of those, right? The problem is that's a very artificial trick, right? In natural language, there is no restriction to the application of possibility to worlds. In fact, I've been doing that in the last 3 minutes, right? Asking about exactly what's possible or not in a world, and you've been understanding what is it that I'm asking about, right? And so it ultimately recognizes a limitation of the expressive power of modal realism, right? I think that's what the problem is here, right? Now, the approach also fails to accommodate the REM modal claims, and that's something that Divers and Perry later on identify. And then they say, well, all you need is a different approach, right? They offer a generalized semantics in terms of absence from counterpart theoretical translations of world restrictions. So they do another complicated operation to try to make sense of the REM modal claims within a sort of modal realist picture, right? The problem is the move is equally artificial, right? And it's not clear that it really addresses the origin and the source of the problem, which is what you need is increase the expressive possibility, expressive resources of modal realism, right? Or give up, the restriction of reducing modality to something reasonable. I think that should be the lesson here, right? So in the end, the modal realist needs to assume some primitive modality to ensure that the structure of the logical space is correct. Only what's possible is exhibited in a possible world. Nothing impossible is displayed in it. Right? But that's a primitive notion. So you're giving up on the reductive project, right? And this ultimately treats the impossibility of A and not A as a brute fact, and thus fails to account for its grounds, right? After all, to assume that something is necessary as a brute fact is not to ground the relevant necessity, right? It's simply to state that the modal status of the relevant item, right? So it is just impossible, not actually offering the grounds for that impossibility. But even there, right, I think even if those considerations are somehow misguided, the law of non-contradiction fails in inconsistent contexts, right? So, of course, the Alithis have been making this claim about the liar paradox for a long time. And of course, you may resist those things as well, I'm not interested in the liar, or you may think, oh, I don't care, and so on. So I'm going to actually give a more interesting case that I think it's not be dismissed, I think, so easily, right? I'm not a dialectist for that matter, right? I don't think that there are true contradictions, things like that, right? But I do think that there are interesting cases of inconsistencies in science and in mathematics that need to be taken seriously, right? So consider the early formulation of the calculus invoking infinitesimals, right? In the hands, for example, of Leibniz, and in different way, Newton, right? Now, infinitesimals are positive magnitudes, smaller than any positive number, right? Since they are positive, they're different from zero, and thus it's possible to divide by them. since they're smaller than any positive number, they are like zero and can be eliminated in the end of a calculation, right? And that's exactly what the Indianapolis, Berkeley complained bitterly about. They said, come on, this is nonsense, right? The whole framework of the calculus is riding on an inconsistency. You cannot do that, right? So consider as an illustration, right? Of, we have a polynomial like this. Suppose we want to differentiate it, well, delta there is an infinitesimal, right? How would we go about doing it, right? Oh, here's how we go, right? We apply, the differentiation properties to the polynomial. You get this equation, right? You simplify, then you get this, right? Now you say, okay, delta is an infinitesimal, it's different from zero. Good, I can divide by delta. Both sides, get rid of the delta there. And, well, it's only one left. But delta is really zero. I can get rid of it. And there you go, right? And what we get is exactly the right answer, right? That we want to get, right? Now, the problem here is, of course, we need care, right? Because if infinitesimal can be taken as zero in some contexts, we could also have this, right? 1 times an infinitesimal equals 2 times an infinitesimal. If they're different from zero, we then trivialize arithmetic and conclude that 1 equals 2. That would be very bad, right? Even if you have an underlying very consistent logic, right? So what's interesting is it's precisely the same inconsistent properties of infinitesimals that have been successfully used to differentiate the polynomial and now unsuccessfully used to prove the arithmetic with those infinitesimal being consistent, right? In fact, trivial. So some care is needed. Now, what's very interesting, however, is that somehow Leibniz operating in an inconsistent setting managed to get exactly the right rules for the infinitesimal count. In fact, those are the rules that we still teach our students today, right? How he did do that, right? How he managed reasoning on the basis of an inconsistent theory, he got the right answers and not any nonsense, right? Because, well, being treated as different from zero and as identical to zero, infinitesimals are inconsistent objects, right? And they, that way, violate the law of non-contradiction. Now, Newton used a different approach, right? He used a method of fluxions involving instantaneous rate of change of varying quantity, right? To do basically the work that infinitesimals did, right? And of course, not surprising, fluxions also would exhibit similarly inconsistent properties, right? But both of them, Newton and Leibniz, operating in an inconsistent setting, somehow managed, as I said, to derive the right principles for the differential and integral calculus. Right? Yet, if the law of non-contradiction has been violated, in this case, it cannot be necessary. What's interesting here is the following. You may say, look, we all know how this story goes, right? And then, 19th century invention infinitesimal were eliminated. And so we don't need those things, the epsilon delta formulations, no infinitesimals is actually needed. Sure, but for about 200 years, the calculus was the only game in town, and in a calculus with infinitesimals, because we didn't have anything better, right? Of course, Newton himself never actually used the calculus in the Principia. I was already introducing a notion of force that didn't match with the metaphysics of the time. He won battle at the time was probably enough, right? But it was very clear that he used to obtain the mathematics for the theory, right? So those who are sympathetic with indispensability arguments are now in a curious situation, right? Because the calculus was indispensable to what was at the time the best physical theory in atomic physics for 200 years. But in that case, you need to involve an inconsistent notion, or infinitesimal. So you're operating with an underlying inconsistent piece of mathematics that violates the law of non-contradiction. Interestingly, without triviality, they were not deriving everything. Right? So one way of thinking about the underlying logic in a context like that is, some form of very consistent logic, right? I think it's bizarre to attribute to them that kind of reason, right? The idea didn't even occur, right? But the issue is how to make sense of what was going on, right? In any case, right? For my purpose here is this is an interesting case, right, of a violation of the law of non-contradiction in a context where indispensability considerations may be in place. Right? So it looks like the law, may not be necessary, may be violated for good reasons in some contexts. All right, final answer about the fourth and final one. The necessity of logical laws is ungrounded, right? It's just a brute fact, right? Nothing grounds on anything can ground the necessity of logic, right? That's what we can learn from what we get so far, right? Attempts to explain the grounds of such a necessity in terms of true conditions, invariant over interpretations or possible rules, all fail. So we may say it's just a brute fact. The logical laws are necessary. I think even these account face difficulties, right? If the necessity of logical laws requires no grounds, one can easily uncover contexts in which the negation of the logical laws under consideration holds. And in this way, question of the necessity of the laws, we question the necessity of the laws in the first place. So you cannot just say, look, it's just a brute fact that they are necessary. Because if that's what you're saying, well, someone may say, well, you can say that it's a brute fact that they're not. If they are the context and they fail. So we have no defense against that situation. And in fact, this is precisely what I have indicated while questioning the validity of conjunction introduction, bivalence, and the law of non-contradiction above. So look, there looks to be a context, in which these laws are violated. And if there are these cases, there's no reason to think that they're necessary, right? Well, in that case, if there are no grounds, right, one ends up losing the necessity of the logical laws, right? And so to become clear in that moment, I think that's exactly the right result that we want. The logical laws are no more necessary than mathematical laws or physical laws or whatever principles that we may have, right? And I do think that similar considerations can be raised to other logical laws from classical, right? They all fail in some context or another. So what to make, right? I think given these remarks, rather than trying to identify the grounds of the necessity of logical laws, a far more promising approach would be denied that such laws are even necessary. It's noted the fact that there are contexts in which the logical laws fail clearly challenges that necessity. And once necessity is left behind, the search for the grounds of the necessity of logical laws will be bypassed altogether. So the resulting conception emphasizes the contingency of logical laws, their fallibility, and the fact they only hold in specific domains or contexts. They don't hold in general. Right? So the alleged necessity of logical laws emerges as a piece of philosophical fiction, an illusion that has been motivated, I think, primarily by the assumption that classical logic is the only game in town. Right? That's one of the things that we learned with the development of non-classical logic throughout the 20th century. Right? There are more possibilities than are being recognized by classical logic. And once the limitation of classical logic emerged, the contingency of logical principles, I think, became saved. This suggests what I want to call it's a form of empiricism about logic, right? Some of the features, let me highlight some of them. Some of it should be clear from what I said, and I'm going to elaborate in one a bit further, right? So, as I mentioned, fallibilism about logics, right? Rather than infallibilism. Logical principles fail in certain contexts and can be and have been revised accordingly. They fail in some contexts. That doesn't mean that they do not apply in others. There are contexts in which they are perfectly good, right? If you're dealing with abstract objects that are not indeterminate, vague, temporally contingent, well, classical logic is actually great. In fact, it was designed exactly for that, right? And Frege formalized, what was then, his version of second order classical logic in the Beck-Rich. That's exactly what CSU is trying to do. For that, classical logic is pretty much unbeatable. And in other contexts, not so. right? Second feature, the context dependence of logical principles rather than topic neutrality, right? Rather than thinking about logic as being topic, doesn't matter what we're reasoning about, logic would be applicable across the board. I think logical context would apply in particular context. So it does matter if you're reasoning about abstract objects, or if you're reasoning about fictional objects, or if you're reasoning about inconsistent objects or quantum objects, it does matter, right? And different logics will be appropriate for different contexts. We also have contingencies rather than necessities. Right? Logical principles are not necessary, but contingent, right? Since they fail in some contexts, right? It's enough. It's your question. They're necessity, as I try to illustrate with the cases that I provide, right? And of course, the one that I want to say a little more about is logical pluralism, right? Rather than logical monism. More than one logic is adequate for a given domain or context, right? So the first three, I think, relatively clear given what I said. So let me close the talk by saying a few things about the form of logical pluralism I have in mind, right? So now, in recent debates, JCBU and Greg Rastel formulated logical pluralism in an interesting way, but somewhat problematic, right? The idea is the following. There is a plurality of logic, but there is something that brings together that plurality into some unity. And that's the notion of validity, the notion of logical consequence. And they said, look, an argument is valid if and only if every case in which the premises are true, the conclusion is also true, right? What matters here is, however, what counts as a case. And by changing the case, we'll end up getting different logics, right? If we think about cases, for example, as complete and consistent situations, so you're thinking about kind of Tarski models, right? Well, then we already get, when you quantify with those cases, is classical logic, right? If you think, however, that the cases are incomplete but consistent situations, you get constructive logics, right? So, because basically you think in terms of you're building objects, right? So it's not determined what properties they have. Think about what you do in constructive mathematics, right? So until the moment in which the construction is performed, it's indeterminate whether a certain object has or lacks a certain property. So excluded middle doesn't go through, right? So cases like those are cases in which a constructive logic will apply. Suppose you have cases in which you have complete and inconsistent situations, right? Well, then you get cases appropriate for consistent logics, right? I gave an example with the infinitesimal calculus, right? So the inconsistent object, right? But the objects are. Now, it's an interesting formulation of logical pluralism, but I think it's problematic. Right? Couple of problems. First, if we take seriously the claim that they're quantifying over every case in which the premises are true, the conclusion is true, right? So we have to actually consider among the cases, all of them, right? We need to consider cases that are complete and incomplete, consistent and inconsistent, right? All at the same time. And if we do that, of course, nothing will satisfy the logical principles in question, right? So what we have here is actually a cherry picking. They're not really considering all cases, right? They're considering cases of a certain sort and restricting accordingly what kinds of logics that we're going to generate, right? But then you put the cart before the horse. You're already selecting the logics and then adjusting your cases as an afterthought, right? And then you don't really have, a proper formulation of logical pluralism, right? Also, I don't think, so in that sense, the view sort of overgenerate, right? So, but also it undergenerates, because I don't think every logic can be cast in this way, right? It's not obvious how quantum logics, for example, those that are available by distributivity, for example, or non-reflexive logic that restrict identity principles in some way, can be formulated in terms of those cases, right? So, and I'm going to give examples of both in a moment to illustrate, right? So I think what we need is a different way of thinking about logical pluralism that doesn't generate that kind of nihilism, but it's more ecumenical in the way in which you generate other logics. Right? So what I suggest is a form of modalism, logical pluralism. I already said why we need some primitive notion of modality in the background. Turns out that I think the primitive notion of modality is crucial because that's ultimately what logical consequence is. It's a modal notion, right? So think about validity in these terms. An argument is valid if and only if the conjunction of the premises and the negation of the conclusion is impossible. But the notion of impossibility here is not taking this period, right? So if you just don't hang together, right? You cannot get those things. And that's the idea, right? Note that I'm not talking about truth preservation. I'm not talking about truth in a model. This is not a model theoretic version, right? I think the model theoretic version has its own restrictions, right? About what can be represented in set theory, for example, right? This is not what I'm doing, right? In a way, I think, going back to Aristotle, whose notion of consequence was in many ways a model notion. And so let's do that. We already need a primitive notion of modality. Use that to formulate what consequence is, what validity is. And then we realized something quite interesting, right? Because I do think that Lewis says that the world is not a modal thing, right? It's maximally extended spatial temporal relation. Right? Turns out that I think the world we live in is actually already a modal object. This desk here is fragile. It has a property. It's a modal property of fragility. Under some conditions, we will break. Right? We bring an elephant to this room and get it sit on this desk, it's going to crash, right? So now it's a property that this desk has. And I want to say that property is well understood, just as the property of being square, they're being made of wood, right? And having a certain color, and it has a modal property among those, right? So modal properties are everywhere, right? So I want to take that seriously, right? And understand that by understanding what these possibilities are, we extract logics that express these possibilities. So think about logics as something that actually results from thinking about properties of things. And not surprisingly, they'll be appropriate for those things that they've been designed to express the possibilities for. I know this is all very generic. I'm going to give examples to illustrate that more clearly, right? So think for a second in this way, right? So I'm taking these possibilities, right? These possibilities are consistent and complete. But we do get classical logic, right? The well-known Tarskian models have all these features, right? And if the possibilities are incomplete and consistent, we do get constructive logics, right? That's one of the interesting features about constructivism, right? And so, of course, there are different forms. You can formulate constructivism in different ways, right? More radical or less radical. But what is interesting is if you're interested in capture constructive features of mathematical reasoning, well, we cannot do that with classical logic because they foreclose a possibility that some consistent things are incomplete, right? And that's a possibility that it's not allowed in classical logic, but that's a possibility that needs to be recognized so that we can, for example, study those constructive features of mathematical reasoning. Similarly, domains that involve inconsistency, right? But as you complete, well, the logic that will recognize the possibility that you may have contradictions, but without triviality, without everything following. Well, it's what we need, right? If you want to study properties of the Russell set, right? Of course, you cannot do that in any classical set theory if they are consistent, right? But in a very consistent set theory, you can. And it turns out that actually the Russell set has interesting properties. It's an inconsistent object. It has some properties, but it doesn't have every property. It's not a trivial object. Now, that is not a possibility that classical logic recognizes, but it's a possibility in the logical space. And once you recognize the possibility, a logic that expresses it is paraconsistent. In fact, there are several such paraconsistent. So the pluralism here goes rampant, right? But this is not the only form. You may have incomplete and inconsistent possibilities, right? And you have a bunch of non-elastic logics, right? So you think about logics in this way. Logics are ways of expressing possibilities in the logical space. Classical logic recognizes one corner of those things, right? For those consistent and complete possibilities. But that's only a fraction of the logical space. Turns out the logical space is richer. There are possibilities there that are inconsistent and incomplete. Others are incomplete and inconsistent. Others are inconsistent and incomplete, right? And the logical space now, it's actually much richer, and each logic is a way of expressing those possibilities, right? That's the notion of logical consequence formulates, right? What's interesting here, other kinds of logic can be recognized in this term. I complain about quantum logic and non-reflexive logic against the pluralism by cases that Greg Russell and J.C. Beale, right? I don't think that's a problem, right? So I don't think we get here logical nihilism, right? Because depending on the possibilities in question, different logics would emerge, right? Sure, there's not one single logic that is applicable to entire logical space, because it's going to be violated somewhere in that space, right? But principles hold limited in some context. In some context, some logics will hold. And you expand this context in some ways, and some of those principles will end up being violated, right? So we don't have logical nihilism, right? In the context in which the logic holds, they're perfectly fine, right? They have validity in those contexts, right? It's just that gets violated elsewhere. In a way, it's not very different than the situation that we have in science with physical theories. We thought, well, back at the time of Newton, that Newtonian mechanics captured the whole of the universe as far as the physical laws were concerned. We learned the hard way with the perihelion of Mercury that is not right, right? So it's still classical mechanics functions pretty well. You can send rockets to the moon with it, right? But if you want to work with your GPS, that would not work, right? You need relativistic corrections, otherwise you're going to get a GPS that will not be accurate enough. So again, a priori, we don't know what the context of the physical theory is. We learn when it fails. Logic's not different, right? Classical logic was thought as having this broad, universal, unified, necessary domain. It turns out that it's not like that. It still works. I think it works very well for classical mathematics. Beautiful for that, right? But not so well if you're talking about fictional objects, fake contexts, indeterminate objects, inconsistent contexts. For those, there are other logics that are much better, right? So we don't have logical needs, right? Also, I think quantum logics can be, there will be a context in which they go through. And those are contexts in which distributivity fails, right? Non-reflexive logics also involve possibilities, which identity does not hold. So we can account in this way by identifying what are the relevant regions in the logical space, what are the relevant possibilities that these logics are going to express. And that's how we get a genuine form of logical pluralism. So let me end illustrating these two cases, an example for the quantum logic and an example of non-reflexive logic, right? And this is also two examples where you can actually violate a logical principle on empirical grounds, which is something that empiricists will be happy to acknowledge, right? So suppose, for example, in the case of quantum logics, right? We have the distributivity principle in classical logic, familiar with that, right? And suppose we are considering here non-relativistic quantum mechanics, right? So we have what we can call a spin principle, right? In a given direction, right? The E, so the proposition E, up Y means, the measurement of the spin of the electron in a given direction, Y was up, right? And the spin principle says, well, measurement of spin of a given electron in a given direction is either up or down, right? These are the two possible values according to non-relativistic quantum mechanics. The other is a version of Heisenberg uncertainty relation. We cannot, it's not the case, right? And you can measure the spin of the electron in two different directions. simultaneously. Right? So that cannot be the case. In part because if you measure in a given direction, you mess up, you disturb the system, at least in the way that Heisenberg was thinking, not Bohr, but Heisenberg thought in this way. So you interfere with the measurement in that direction, so you cannot also measure in a different direction at the same time. So that's why you cannot do that, right? Okay, suppose we are in the lab, we prepared the system, and we made a measure of the electron in the direction X, right? And it was up. So that's true empirically, okay? Now, suppose our context is a classical context. If it's classical logic, if I have a true principle, I can always make a conjunction of that true principle with another truth. The truth in that case is the spin principle. In a given direction, the measurement of the spin of the electron is either up or down. That's a classical context. Apply distributivity to that principle. Distribute conjunction over disjunction, and here's what I get. Well, what I have is then something interesting, right? This guy here is empirically true. This is true given quantum mechanics, but this one is false because, look, I cannot violate the Heisenberg relation if I measure the spin of electron in two different directions, which I did in both cases, right? So I violate distributivity, right? A simple example that illustrates how empirically, if we assume non-relativistic quantum mechanics and classical logic, we get a contradiction. Something has to go. Now, if you're a hardcore classical logician, you may be unmoved by that. You say, no, we're going to still hold on to distributivity. I'm going to change quantum mechanics, right? That's what Bohm did, right? David Bohm said, okay, I'm going to make a formulation of quantum mechanics and make the Heisenberg uncertainty relations do not hold, right? And that's what he did, right? So you could be a Bohmian and resist this argument, and that's perfectly fine, right? Of course, there's a cost. You need to find the quantum potential, right? You have evidence for the existence of those things, right? That's one of the issue with Bohm. That's why probably Bohm wanted a rival theory to quantum mechanics. He ended up with something that was a different interpretation, right? So there are some options, right? I'm not saying that that there's no option here, but the option has its costs, right? So you need to consider the alternatives. Final example, non-reflective logics, right? So those are logics in which the principle of identity, right, that everything identical to itself is restricted, right? Not that it's that it's denied, right? The idea is that for some objects it doesn't make sense to ask whether they're identical or not, right? And the idea, and it's a version, it's a formulation of quantum mechanics that you find in Schrödinger, for example, and that say the following. Well, if you have, say, two electrons, right, in the same quantum state, right, and you swap them around, right, then that does not change the state that they are in, right? So in that sense, it doesn't matter which electron is in that state. As long as it's an electron, doesn't matter which, the state will remain the same, right? That's very different from what happens, say, in classical mechanics, right? And so the thought here of those that kind of interpretation of quantum mechanics is to say, well, then the identity of the quantum particles is not something that makes sense. Right? Techniques that individuality, right? As Weil said, here's Mike or Ike. There's no alibi for an electron. I don't know which of them, was involved, right? You cannot find individuating principles for those electrons, right? So the idea is, well, it doesn't make sense. You ask, is that the same electron, right? And according to the quantum mechanical formulas, right? So here's the, and that has implications in the way that quantum probabilities are introduced. So in classical mechanics, for example, suppose we have two objects in two states, right? Well, there are four possibilities, right? There's two objects in one state, none in the other. No objects in the first state, both in the second. One object in one state, one in the other, vice versa, right? And so these are all four possibilities, right? If each possibility has the same probability, well, then we have probability 1/4. However, In quantum mechanics, the situation is different, right? So if I have two electrons in a state, right, in two states, well, first I cannot label the electrons A and B because, well, that already assumes the individuality that they lack. I know only that there are two electrons, right? So I have two electrons in one state, none in the other, no electron in the first state, both in the other. And then I only have one possibility, right? Because if I swap around, that doesn't change the state. So in that case, if they have the same probabilities of these possibilities, these alternatives, what you have is 1/3. So, and what's interesting is this is exactly the probability that we get on empirical grounds, right? So what's interesting in those cases is it looks like a logic that doesn't presuppose that objects have identity, right, may actually be better equipped to make sense of those quantum probabilities. Right? Of course, there will be other problems with those interpretations, right? That's one of the things we learned from quantum mechanics. Something weird is going to happen somewhere. You just have to see where you're going to be happy with living with the weirdness, right? But the point here is, this is another example of a situation where you may revise a logical principle on empirical grounds, right? Something that an empiricist would be happy to acknowledge. And that's another illustration of ways in which logics depend on the domains that they are reasoning. Right? It matters if you're thinking about quantum objects or classical ones, right? That's the idea, right? So to conclude, once logical necessity is no longer required, none of the difficulties examined earlier regarding grounds of logical necessity apply, since they all depend on the necessity of logical laws. This is, of course, part of the development of an empiricist view of logic. Not a view according to which logical principles, rather than laws, are derived from experience, but one in which the principles can be empirically refuted. And we learn something about those domains by identifying these refutations. Now, pure logics can be studied as any piece of pure mathematics, right? Irrespectively of any applications, right? But once you apply logics, then we need to think about what the domains that we are using them to reason about. And that's where those principles might be undermined, empirical, right? I think this is a form of empiricism about logic, right? It doesn't at least face the difficulties that I complain about in the first half of the paper, right? I'm sure it faces a tons of other difficulties, but at least it's worth taking seriously. Thank you very much.
Thank you. It's very interesting.
Thanks.
I guess I want to question the idea that the fact that classical logic works only in its domain of applicability means that it is not necessary. You know, if I take a logical operator and I put into it things which are not propositions or Boolean variables, then you know, it doesn't make sense. And so the laws of logic won't hold, but it would seem unreasonable to blame classical logic for that. And I'm thinking of the quantum case specifically, because it seems to me that what happens in the quantum case is that, you know, we're treating quantum measurement outcomes as if they are Boolean variables, and then classical logic doesn't work, and then we say that's a problem with classical logic. But you know, I think quantum measurement outcomes are not Boolean variables, and so it's sort of not surprising that if you apply logic to a thing that's not a Boolean variable, it doesn't work. So I don't see that as undermining the necessity of classical logic.
But then, in what way, right? Are you reasoning with classical logic in this context?
What do you mean?
Well, because the issue is, there are features of the domain, and expressing in terms of the Boolean operations that seem to clash with the distributivity of classical logic.
Right, because they're not Boolean variables, so you shouldn't be applying classical logic to them.
And what do we apply? Which logic?
Well, you should apply classical logic to propositions.
No, but those, yes, but I'm talking about now the quantum ones. What logic are you reasoning when you're reasoning about those?
You can certainly use classical logic to describe everything in quantum mechanics, but you have to be careful about what the allowed propositions are. The propositions, for example, about measurements which are not performed shouldn't be treated as Boolean variables because of contextuality.
Yes.
So it seems to me that by applying logic to something that is not a Boolean variable, I mean, of course, it's not going to work, but
Yeah.
that's not a failing of classical logic. That's a failing of applying it to the wrong domain.
But that's what I don't
logic.
see. right? Because once you get the violation of distributivity, it is a failure.
But I mean, I could also get a violation of distributivity if instead of putting propositions into my logical operator, I put like apples and oranges, because the result just doesn't make sense because it's not the right kind of object to apply logical operators to.
I'm not sure that the analogy goes through, right? I don't think there's a category mistake here.
I think there is, yeah.
Well,
But von Neumann thought there was.
yeah, well,
When he-
what I would
when he
suggest,
retracted everything he said about quantum logic and said that was the wrong path.
no,
That's almost exactly what he said.
well, there are different things going on, right?
Yeah.
So one thing is, when von Neumann, Birkerup and von Neumann wrote the paper, right? That paper was a paper about the geometry of quantum mechanics, not about the logic of quantum mechanics, right? Despite the title being the logic of quantum mechanics. So there's a sense in which that is not a paper about logic. That's about geometry, something quite different, right? Now, then von Neumann developed the Hilbert space formalism, right? And thought, okay, this is the way to go and so on. And interesting, he was a logical pluralist. He thought that there actually, depending on empirical domains, different logics will go through. He thought, he even went as far as, you think the probabilistic logics were not classical either, right? So in fact, he was, the sort of domain dependent form of empiricism that I have, he would subscribe to it.
I'm not sure I agree with you on that.
I'm not necessarily objecting to the idea that it might in some contexts be useful to use different kinds of logic. I think I'm just objecting to the claim that because classical logic has a specific domain of applicability, that means it's not necessary.
Okay, I take necessity to be something that holds in every domain. If there is a domain in which something fails, then it's not necessary.
But I mean, if you're taking something which is supposed to be which you're considering to be necessary and applying it to a domain in which it doesn't fit or it doesn't make sense in,
But
Let's
then it's not necessary to begin with. Right?
but
If
again,
there-
if you take something that's not even a proposition and you put it into a logical operator, then of course that doesn't make sense. But it doesn't seem like an objection to logical operators because they're supposed to work on propositions or Boolean variables.
Yeah, well, note that the example I gave, I don't think there was, a category mistake. Right?
Well, I think in the
So,
quantum case there was. Because
uh,
I think you were treating, for example, the spin in the y direction as if it was a Boolean variable which has to be true or false. I think quantum mechanics shows pretty clearly that's not how you should think about spins.
Well, it does have the feature, right, that in a given direction, either it's up or down.
No, only if you measure it.
The measurement of the spin of the electron, right, in that direction.
Right, but you
There
can't
are-
measure both x and y
You
together.
cannot, that's exactly the Heisenberg principle.
Yeah, so therefore you shouldn't treat spins as being Boolean variables, which must be true or false.
So,
But you can treat measurements of spins
Yes, but you can't,
as
yeah.
them, and then shouldn't his example still work if you,
Well, his example combines two measurements that you can't both perform both of those measurements. You can't measure
yes,
both.
but look, but classical
Where in
logic,
which that can.
allows me to do just that. Because classical logic says, look, if I have a principle that is true here, another one that is also true, I can always conjoin them. But there are no restriction about how I actually apply conjunction introduction in
Well,
classical.
no, there
logic.
is a restriction because you can only apply it to propositions or to Boolean variables.
That's not a law of classical logic. Now you're adding a particular interpretation of quantum mechanics to restrict the use of a classical connector. Classical logic doesn't have that
And
restriction.
again, it does have a restriction that you have to apply it to objects which are suitable to do logic with,
Yes, and yeah,
such as propositions
yeah,
and Boolean variables.
yeah. So, okay, so now the issue is the issue about interpretation, right? How to interpret those statements, right? And that's what we are disagreeing about, right? I think you're sort of overriding, offering an interpretation that would restrict the application of classical logic in a way that I think that classical logic has no such restrictions, right? Quantum mechanics says nothing about propositions. a theory of proposition is not part of quantum mechanics. So you're adding something to an interpretation of the theory and said, okay, here's what counts as a proposition.
But I think you're adding an interpretation by trying to use classical logic in a certain way, because then you are assuming that certain things are Boolean variables or propositions. And my claim is that there's at least one natural reading of quantum mechanics in which such things are not propositions or Boolean variables. And so I'm skeptical that it is reasonable to apply classical logic in this
Good.
way.
Perfect. So what you're offering now is a way of saying, okay, I'm adding an extra interpretation principle to quantum mechanics.
Well, no, I think
Right?
you're adding an interpretation principle because you are treating these things as propositions.
No. Okay, so I think you're adding to resist, to keep classical logic, right? I don't think I'm adding it, but that's where we're disagreeing, right? But the point here, right, is the following, right? Classical logic has no such restrictions, right? Classical is supposed to apply across the board.
Two
Right.
propositions.
To propositions, yes. And quantum mechanics has nothing about propositions,
Right, so
It's completely silent. right?
by extracting something from quantum mechanics and treating it as a proposition, that is an interpretative move that you are making.
I'm not, you are.
Well, no,
But okay.
I'm saying I don't know the proposition.
E of X is a proposition.
Yeah.
You've connected it with propositional connectives, so you are making.
Yeah, I say, I made a measurement.
Emily's right.
Yes, I made a measurement, an empirical measure, right?
The measurement is expressed in a proposition.
That's correct. It is expressed in a proposition, right?
But you
And-
couldn't.
But
you
the
couldn't- all of
Heisenberg
the things
principle-
in that expression are measurements you could actually do. You couldn't do all of those measurements.
I think that the discussion needs a German.
And now- And now you also,
I was leaving the discussion go, but that is clear, the discussion needs a German. So, Emily, did you finish? Okay, you.
so wait, the measurement is a proposition, fine. But Heisenberg's principle, you're also saying that constituents of that principle are also propositions. And that's where things fall apart, right? It's not the principle, it's the fact that you've got these two constituents of it with this or symbol in between.
Yes.
Wedge. That's, I think, my objection and Emily's, is that that means you have interpreted those things as if they were propositions. So you've made a move that I think you and I agree is a little bit,
I really don't understand why it's not a proposition.
I didn't say Heisenberg's principle isn't, but the constituents of it.
And, but the constituents are, I make an observation, upspin, the disjunction symbol, and I make an observation, and because it's a different particle, or it's
Yeah,
been
same-
the other way.
Same particle in
Same
the,
particle,
and the spin is.
and it's going the other way.
No, you can't make both
But you
of those
can't do
observations.
those.
Oh, yeah, okay, like you can't make P and not P both true at the same time. That doesn't mean that they're not propositions.
But I mean, the content of that proposition, yeah, the idea that they're expressing a fact, it assumes that there is some underlying fact about that particle, which it means that there is a fact about what would have happened if you did the other measurement. And that's what's not true in quantum mechanics.
Then, sorry, I know, like, another point, but I think that I agree with, okay, that's your view on how propositions work, not.
Yeah.
But I think it's way more interesting to say that you think that even if it only applies to Boolean propositions, it's necessary. I want to see you two fight about that, but we can also go to a different.
Can I express my surprise
That's also not what it
in
She did say that at one
being a
point.
partisan of quantum mechanics to defend the classical logic? That's okay. There are other questions connected or unconnected to that?
So
Go.
yeah, unconnected question. What is the possibility? Because when, like, I'm happy to be like, yeah, classical logic doesn't hold for quantum mechanics. I guess actually, so far everyone's on board with classical logic doesn't apply to quantum mechanics. But when you got to that point, what I was expecting you to show was what kind of possibility is the one that we plug in to your validity principle and we get out a quantum logic.
Yeah, so the thought there is the thought, right? So the quantum domain is a domain in which distributivity doesn't go through, right? So, and that's one feature of this domain, and in part it is for the reasons we've been discussing, right? And so that constraint the use of classical logic, and not surprisingly, quantum logics are non-distributive, right? Exactly to prevent that kind of inconsistency. So so then what will happen is, given the other example, the non-reflexive case, so again, particular interpretation of quantum mechanics, right? So the quantum particles do not have a defined identity. Right? So doesn't make sense to apply identity to them. Is this electron the same as this other one? Given the quantum mechanical descriptions, right? Nothing distinguishes this guy electron from another. You swap them around and the state remains the same. Classical logic would say, well, we cannot do that. If there are two electrons, right? They have to be different.
Yeah, so I just guess that my concern is that like the principle that you propose of this validity principle isn't doing any work if all it's telling us is like, or like it's a purely kind of like philosophical move to be like, okay, we have these different logics, and what's happening is that they're just talking about different possibilities, right? And so like that's obviously helpful to be able to understand what we're engaging in when we do these different projects. But I'm wondering if we can put more meat on the bones and say like both, I guess, kind of like what it means for something to be a possibility, because to also be like, you know, you clearly think that Beal and Restall's way of understanding possibility in terms of cases is inadequate. So it's like there are more that you can say about like what makes something a possibility, or alternatively, because like also that might get very metaphysical very quickly, like what is like in fact like can we say things about what quantum possibility is that isn't just taking observations about quantum mechanics and then putting it in a logical vocabulary?
Right. Yeah, well, first, remember, I think the notion of possibility is primitive, right? I'm not gonna tell you and define, okay, possibility in terms of something else,
Yeah,
because that's what I don't think can be done.
yeah,
Right? Any more than I can define identity, right? You may say, oh no, in second order logic, we define identity, right? Leibniz law, X equals Y, they have exactly the same properties, right? Well, it turns out that you need the same X on both sides of the equation, playing the same functional role to capture the content of Leibniz law. So you use the notion of identity to define identity. So that's no good, right? I think that's an example that illustrates why identity is such a good primitive thing, right? We cannot define that thing. I think modality is in exactly the same boat. By trying to define what's possible or necessary in some non-modal terms, we'll face the same problem. So I cannot give you, okay, a more illuminating account about what's possible, right? For that reason, right? That doesn't mean I cannot say anything about what it is, right? Well, things I can say, well, what's possible, things that all go together, right? I can give you some intuitions about, ways in which we operate, but it's not, in a certain sense, we find out about these possibilities, right? By uncovering the logical space, by exploring what they are, right? And we uncover those things when we run into trouble, right? in fact, it's not surprising that quantum logic was invented as a response to perceiving consistencies with classical logic and features of quantum mechanics. So in that sense, what we get there is exactly violations of validity. Right? In that sense, that's where the validity principle comes in, right? Because there'll be things that are considered valid in classical logic that are then violated once we add distributivity and quantum mechanics, right? Or at least in the way that I was thinking. They disagree with that, and so okay. But that's the idea. That's how I think the notion of consequence is being used there to identify features of the quantum domain. They are dependent on quantum mechanics, right? We cannot discover those things a priori. Right? You need to explore those possibilities. And when you run into trouble, you realize, okay, you need to backtrack, right? It's actually a reasonable approach is we start with classical logic and go as far as we can. It's a good logic, right? For logic, all very nice features, right? When it starts falling apart, right, then it's where we say, okay, if there is something that needs to be expressed, that the logic prevents it from being expressed, that's an indication that we need to identify something in the logical space. And that's where new logics come in. Right? They express these possibilities.
Pino.
Thank you very much, because I think I appreciated what you presented. I don't know if the question is possible, but I try. In which logic did I listen to the talk?
Yeah.
This is
So-
exactly.
Yeah. So I think, as I said,
Okay,
I
so
start.
context.
Yeah, exactly. Yeah, I start. Look, we use classical logic as the default logic, right? We start.
Hold it. You.
No, well, I think no. Wait.
Okay.
Yes, not everyone does.
No. Look, I'm a logical pluralist, right? So we start with a logic, that's as strong as we can, right? So now, if it turns out that there are assumptions in this logic, right, that we started, that are preventing me to express what I need to express, that's an indication that I need to backtrack. Now, we don't want to change logics lightly, right? Because I don't think, oh, I said something inconsistent, I said, oh, no problem, I'll change to a consistent logic, right? That's a terrible way, right? You don't want to do that, right? Because not everything is resolved by changing the underlying logic. You change the underlying logic when the logic you have doesn't allow you to express the possibility that needs to be recognized, right? So sometimes I may not be aware of those. So I start with a logic, as strong a logic as I can have, right? If it turns out that you point out to me that, oh, look, my argument here somehow illicitly presuppose excluded middle, right, at some point, and you think that, that matters for what I'm saying, well, then I need to reconsider, right? I don't think that there is a meta logic, underlying what I'm saying, right? It's logical pluralism in every context.
That's
Can you go back?
that's I do not understand.
Go back a page to show us your Bell star again.
Yeah.
I think that's what I want to understand. So it's valid. So how am I to understand the words conjunction and negation?
Right. Yeah. So again, so we have the question is, am I assuming a logic, right? Now, we always are assuming, right? Always. Now, logic is a regimentation of inferential procedures, right? It's not by surprise that when Aristotle regimented it in the way he did, there were centuries of people arguing and using patterns of reason, right? So we always have a logic. We may not be aware of the logic. It may not be made explicit, right? So then when it matters, we pointed out, okay, look, if that logic here cannot be classical, is why that's the case, right? So I don't think it's a big deal out of it, right? If there's some limitation in assuming a certain logic in this context that I need to restrict, okay, I restrict.
That seems fine, but I think it's worth pointing out then that val star is not just parametric on your notion of possibility, but it's also parametric on On what you mean by conjunction.
Yeah, yeah, of course, as with any, look, the notion of logical
Yeah,
consequences
I-
is like that, right? Even the model
I
theoretic.
think I'm actually agreeing and reiterating what you've been saying, which is that we even have to understand that sentence
Yeah, I
in a
agree.
pluralistic way.
Yeah, I completely
Which
agree.
maybe gets you linear logic, for example, because conjunction there means you've used a resource.
Yeah.
And you don't have the structural rules.
Yeah.
For example.
For example, yeah, I agree.
Pino, want to conclude and then?
No, I wanted to follow up on your comment. Yes, I think I agree with Drew. I was wondering actually if it is really conjunction that we want to address, or rather, as you said, logical consequence. So the relation between two statements, I think you've done. In fact, I'm not sure. Do you really mean incomplete or inconsistent as the negation of consistent and complete, or as a notion by itself, which is incompatible with consistency, for instance, but it's not really the negation? I just wonder, because I mean, the pluralism of logic would probably allow you, in the end, to argue about something and also argue against. That's the same thing. So it's, in some sense, there must be some, I'm not sure I know what I want to say, but some consistency.
Oh, that's right. We need a primitive notion, right? Whenever you're reasoning about something, we're holding certain things fixed, right? Certain things go together, other things do not. But it's not, look, the logical pluralism here, right? The notion of all starting here is not, look, there's no logic, and I'm going to build out of nowhere, out of thin air. That doesn't make any sense. We cannot do that, right? Logics are already being used, right? Logic is something that will come later in the day, right? After people have been reasoning in however way they have been, right? And logic's a way of regimenting certain patterns of it, right? So I think, I'm not suggesting that this is, ground zero, and we're going to start from scratch. I don't think we can do that, right? In fact, we are not in that situation. We know too much about logic at that point to be able to say something like that, right? So yeah, I agree with you. We need something go together. We need some notion of consistency that we are holding together, right? And that's the idea about the possibilities that we are considering, right? And I don't think that I'm tied to one particular logic, right? Of course, as a methodological principle, we start with the strongest logic you can, and because that again more consequences, right? So it's reasonable, right? And when you run into trouble, you backtrack and you say, okay, maybe that was not the proper way to start.
Okay, the two things. Maybe first thing about the last thing that you said. I think we should start with the weakest thing, with the weakest logic that allows us to say whatever we want, and whenever we need something else, then we add it. But
that's very artificial. I don't think we do that.
So I think in order to make this point, maybe I only need my conjunction and then my negation, and that's it. I don't need anything else.
Yeah, that's what I need to get validity, right?
In any case, here, what do you mean by complete?
Well, the idea is it's not, indeterminate whether something has a property or not, right? So that's
so for example, when I say when I say classical logic is complete, what I mean is that for every formula, either that formula or the negation is a theorem.
Well, here I'm talking about the possibilities, right? So either for a given property, either an object has a property or it does not have. That's what I mean. And in the possibility at hand.
The object is complete.
Yeah, I'm talking about the object.
Or any predicate that the object has it.
But
For example,
that,
Anna Karenina
Yeah.
complete because
That's
there
right.
is no sense inside that there are even or odd number of
Exactly.
pieces.
Yeah.
If you understand.
Yeah, that's the idea. Yeah. Right, the possibilities are complete. Right, because the idea is we're reasoning locally, right? We're reasoning about certain subject matter. So we say, okay, in that subject matter, I was reading about Anna Karenina, right? And then we're reading the novel, and then I have this idea. But the number of hairs in her head is even or not, right? And so in that context, there is no fact of the matter to settle one way or another. So Anna Karenina is an incomplete object, right? For some properties, it's indeterminate whether she has that property or not. And there's nothing else that is missing that I could add in a principled way to settle the matter, which is different, right, from a real person. I could go there and count the hairs if I have nothing better to do. So
You are able. Your case is
in my
very.
case, it's very easy. Yours is a different matter.
Yes, it's some use maximal instead. Right. So this-
Sorry?
Some people use maximal instead for this.
Yeah, okay, well, that's, maybe it's not, I'm following the terminology that, Bio and Russell use, but maybe I can see why, it might be confusing, because if you think about completeness of a logic, well, that's something completely different. It's not what I'm talking about here, but that's the terminology that they were using, so
Yeah,
just
and like-
following along.
I think that I resisted
I would say
enough.
Definitely.
Now I want to speak. No, Pino in some sense made a version of what I wanted to say, but I want to try to follow the same direction, possibly in a little bit more elaborated way. Okay, you say, okay, start with the strongest logic that I have, or if you want to follow the suggestion. You start from the weaker and you add, or start from the and you eliminate. Okay. But at a certain moment, you are arriving at the end of the reasoning. You stop the conference. Conference finished.
Yeah.
Conference finished, and I hope that you convince us. Okay. Possibly we do not convince us, but I hope that you convince us. And if you hope that you convince us, it is because you think that you present something as if you don't want to say valid, good argument. Because if you were convinced that your argument is bad,
Why bother giving?
you could say, okay, I can convince them because they're stupid. But you should support that you are not stupid. So you are convinced that you hope that you convince us because you think that you presented a good argument. Now, front of it, we have two possibilities. Either this argument is good independently of the logic that is embodied in the argument. So there is nothing as being good because the logic is in it embodied, is validated, or is good because it uses a good logic. So this logic is necessary for you, because this is what you use in order to construct what you think to be a good argument. Why not?
Okay. One thing is, of course, I take out the logic I'm using, right, as a logic that holds in this context. That doesn't mean that that logic is necessary. It may actually be a bad logic in somewhere else, right?
So this I contest, because this is not a contest among others. This is the context in which you argue about the necessity of logic.
But that's one context. I don't think that there's anything special about it. That even that context is a limited one. In a way, this is a very narrow issue. It's not a general issue. It's a narrow issue about, okay, what's the modus?
Okay, so let's say in another way. It is not a context, it is a meta context.
I think the same thing goes in the meta context. There is no difference, right, between them. I'm not sure that in fact, I think that distinction, language, meta language, those sort of distinctions are distinctions that are very artificial, right? What makes natural language so interesting is exactly that there are no such distinctions, right? And that's part of the richness of the expressive resources of those languages. Once we start separating this context and the levels and we impoverish what we want to say in artificial ways. So my response to you is, sure, if you want to look at a meta context, it's okay, that's same thing just upstairs. I'm going to make exactly the same argument upstairs that I made. And if you wanna push me, we'll keep going on. I don't think that there is a difference in kind.
Okay, so let's make the following convention.
Okay,
I call necessary a logic that I use to argue that there is no necessary logic. This seems to me a quite reasonable stipulation. Now you have a definition of necessity. It's stipulative, it's a pure stipulation. It seems to me a reasonable stipulation. The logic that is necessary is the logic that I need to use in order to argue that there is no necessary logic. This is a version of the logic.
Okay.
So I'm inventing nothing. This is the kind.
okay. So let me, I think there's a problem there, because I don't think there is such a logic, right? If you have one logic that applies to this context, there's actually going to be an infinitude of other logics. There's going to be an infinitude of other logics that are going to agree with that logic in that context and disagreed elsewhere. Right, so simple example. Suppose that the logic we are reasoning about when we give the necessity of the argument here is classical logic, right? Well, it turns out that classical logic, the context we're dealing with, is a consistent one, right? Turns out that an infinitude of paraconsistent logics would validate exactly the same inferences in that context, but they diverge elsewhere. Which of them are we using?
In this case, I use an argument very dear to my dear friend Drew that say, okay, the common kernel of the logic is exactly the logic or the good logic. This is exactly where we start.
Yeah.
By the Euclid argument.
But there is no common.
So I say I let me say it in a more positive way.
Okay.
I agree in the end of the story with you that logic is not necessary, that there is a logic pluralism, etc., etc. But I think that what makes a logic plural is not the fact that in a one logic I argue one principle, or another logic I argue another principle. What makes logic, the difference of logic, essential is not the principle that I use, is the real structural morphology that is different. So when we try to make the logic of Euclid, what we are doing is not simply to deny that or deny accepting that. We change completely, we try to change completely the idea of what the logic is. Okay, and so this is what could make a pluralism of logic applicable. If you share a certain structure, what make a logic, you need some principle, you need a certain language, you need a certain principle, etc., etc. Then, if you do it, you are forced to use the same structure to argue about this logic. And so it seems to me that you are required to agree with you that the kernel is something that you take for granted.
Yeah, well, I need to see because.
Yeah, we should talk about that
Yeah.
over dinner, over a beer. Yeah.
But I have also a question for Emily, because there is one thing that I found interesting in what you said, but I want to understand better. You said in the beginning, the very first claim that you made was the fact that a logic does not apply to a certain context, does not make it not necessary.
Yes.
Okay, very interesting. But what my question would be, according to you, what would make a logic that does not apply in a certain context necessary? What would make it necessary, even if it does not apply to a certain context? So, if applied to all contexts is not the same as necessity, the question is what necessity is for you. It could be very interesting to have an answer because it would be the alternative answer.
Yes, I mean, I don't necessarily have a fully worked out answer to that question. I'm skeptical that the idea that something has a domain of applicability means it couldn't be necessary. I think it would be unreasonable to expect classical logic to apply if you put in things which are not propositions. Classical logic is supposed to be assertion about the behavior of propositions under certain manipulations. If you're not applying it to propositions, then it's not going to work. And so, yeah, I agree that the question of exactly how you should understand that necessity is an issue. I might be inclined to understand it as analytic in nature, maybe, but certainly, I think that the fact that you have to specify what kinds of things you're allowed to apply it to doesn't mean it's not necessary.
Yeah. So no, it's interesting because then what I heard you saying was the following. This is what I offer here is not a counterexample to distributivity because, well, you're not applying classical logic. It's not, you cannot even apply classical logic, and so it's not being violated.
Right, because that they're not.
So in that sense, this is separate from the idea that, well, a logic might be necessary, even if it doesn't apply to everything. Because I think those are separate things, right? I take that necessity requires application across the board, right?
But again, you can't apply
No, I understand.
to anything at
No,
all.
no, that's right. What we are understanding is what counts as the application,
Yeah.
right? So of course you cannot apply if you're making a kind of mistake, right? Then it's not an application.
Yes,
It's
but I
not a
do not
violation.
want that we come back to the previous discussion, otherwise we.
No, but
My
it's,
point was a meta question. So if applicability in our context is not a mark of necessity, what seemed to me a very reasonable idea of what a necessity could be, but I agree that we can have another. If the application of our context is not a marker, a sufficient condition, not a necessity, but a sufficient condition for necessity, so what as another possibly condition for necessity, if not that?
Well, I also don't agree that what's going on here is not the issue is not so much that it's not applicable in all contexts.
yeah,
It's just that
exactly.
some of these applications are not proper applications. That they're
Yeah,
not
Okay, that is another.
yeah, exactly.
That's
And I
another.
think that's what the issue is, right?
Okay.
Yeah, she's.
Giselle,
So, but you're saying that.
Giselle wanted.
Sorry. No, I didn't see you. Go ahead.
Hi, Otávio. Thank you for your talk. I was holding my Wittgensteinian horses until now. Okay, but it's time.
It's.
No, I'm just wondering if this discussion about the notion of I notice a certain circularity in the discussion because of the idea that you are departing from the concept of necessity as this that is applicable across borders somehow, okay? And then because we are, for me, what's confusing is, are we talking about the necessity of a particular logical principles? Are we talking about the necessity of entire logical systems? Are we talking about the necessity of, you know what I mean? Like, there is a certain vagueness, I think, in the discussion, and then
So
for me,
what's
it's kind
exactly
of
my
hard
point?
to understand, what are we really talking about?
Yeah.
Now, from my Wittgensteinian perspectives, many of these problems don't even, arise because I would say perhaps, very loosely Wittgensteinian, if you like, perhaps more attached to the idea that necessity is something that we can experience being a logical system or with respect to particular logical laws, insofar as that logical law, let's say, is a regulatory normative inside a system. So there is a certain function for it, right? So we do certain things with certain principles, and that makes it necessary. It's just this normative way of seeing. So it doesn't have anything to do with objects or what are we talking about or whatever. It's just the regulative role of a principle inside a system is what makes that principle necessary.
Yeah.
And then my invitation would be, if you accept for a moment to accept my position here, do you think that all these problems would arise, or it's not a plausible alternative to think necessity in terms of the regulatory aspect of a certain principle?
Yeah, that's a really good question. And I think it's a very different notion of necessity, right? And especially because it moves away from the objects. It's deliberately, it's a normative claim about the function of these notions. And I want to do exactly the reverse of that, right? What I want is to bring logic to the ground and say, actually, the logic will come from reflection about the objects, right? It's a very opposite. So
it's a big disagreement.
I think it is. It's a fundamentally different way, right? Because you want to put something from the top down, right? And normativity, and then you get the necessity out of. Well, let's,
I'm
that's,
not sure if it is top down. I just think that it is more about the role that certain prepositions have
Yeah.
inside the logical system. So if the role of that preposition is to allow us to make inferences, then it is a norm. It is a rule that I am applying. So as a rule, it cannot be a proposition. So yes, you're right. It's not, I don't equate logical necessity with truth. So perhaps that's the really.
okay,
you
yeah,
know,
that would be,
deep.
yeah. Yeah, but it's a very different strategy,
Yeah.
right? Because I tend to, in part, as part of the empiricism, I look at the objects, right? And try to extract the logic out of that, right? So it's a very different way of approaching. Now, they may have certain things in common. I think, I'm not focusing on truth. I don't think that's it's a relevant notion here, right? In a way, I think we would agree with that, right? But I do want to, I think about logic as those things that come by thinking about the
So your presupposition is already empiricist, because you're making a parallel between empirical objects and logical objects, and then look, the presupposition itself is empiricist.
Yeah.
While, from my view, that presupposition is not, okay.
Yeah.
Good to know wherever you're at.
Yeah.
Thank you.
Good, thank you, yeah.
I
I
have,
think you had a question.
No, it's okay.
I have,
We'll have
I have another question if I can.
You're the
I was
chairman.
gonna say no.
You're the chairman.
Necessary. So you should recognize that you're very quiet for all the talk. Very quiet. No, I'm sympathetic with the fact that logic is empirical in this sense. But what I wonder is, in order to argue for that, you really need to argue the logic is not necessary. So I want to say, why not to say, okay, I do not know, I am agnostic about necessity. I even do not understand very well what could mean for a logic to be necessary. All what I do, what I know is the following, that when I wanted to organize my reasoning about a certain context, was context, domain. About a certain domain, I reason in a certain way, and the logic, the appropriate logic is this one. When I go in another domain, I reason in the way, the appropriate logic is this one, etc., etc. So what is logic? Logic is the tentative to describe at the maximum level of generality the law that seem to me govern a certain domain. And so there are a different domain, different law, so different law. Then is logic necessary? What care? And not this problem is not there. The problem is the anti-Lutherist, because they recognize the fact that the logic is descriptive.
Yeah.
Why you are not content with that? This is my position. Why you are not content with that?
Yeah, no,
I don't know whether it's necessary or not.
well, it's just that I started with the traditional conception that offers an answer to the question of why logic is necessary. Right? And the conception was it's necessary because it holds come what may, it holds unrestricted in every domain. And I say, well, and I look at those cases, you may not agree with them, but I look at some of those cases and it seems to me that some principles of classical logic got violated. Well, so then it cannot be necessary, right? Because they fail in some contexts. So that's why I was led to that conclusion. Now, if you took a step back and said, look, I don't even know what necessity is, right? So
I wonder whether the category of necessity is a good category to be used in order to evaluate logic.
yeah.
And it seemed to me that was really relevant is not whether it is necessary or not, but whether it is unique or plural.
Yeah,
My argument is fatally plural.
yeah, I agree with you completely about that. In many ways, look, what I'm trying to do is dispense the grounds of logical necessity, right? As well, if what I said is right, well, we don't need to, right, settle those issues, right? But I do think that pluralism.
My point here that your tentative is not because you are not good enough. The problem is intrinsic.
Yeah.
Your tentative, in your tentative, you are fatally exposed to circularity. And all this debate show the danger of circularity.
Well, what do you mean by this circularity of what?
What was discussed in this domain, what we said. So the very question that you are trying to attack is a question that make very difficult, even for God, not only for a very good philosopher as you, even for the best possible imaginable philosopher, that you are not, because you are not God, close, but not God. Even for this philosopher,
Right.
the risk of circularity is intrinsic.
Yeah.
It is tentative. It's not surprising that we all appreciate our talk, but anyone who has a certain objection.
Yeah.
Because the objection, I think, what I suggest is do not try to do it. Why we should try to do it? What is relevant is not what is necessary or not relevant. It is logic is plural. This is all what matters.
Yeah. It's interesting because I think that conclusion, I'm happy with that. And in certain ways, I think that's what I'm trying to navigate toward. But I think with an argument, right? And the argument is, well, if that's what we understand in a sense.
The argument for me is purely experimental. I look at that use this logic when I want to speak about law, not law, double negation mirror, law, juridical law.
Right.
I use this logic when I want to speak of values. I use this other logic when I want to speak of etc. So my argument is simply experimental. I see that logic is plural.
Yeah.
I see it, but I don't need an argument. It's like I do not need an argument to say that this is right. I see that it is right. Why should I need an argument?
Well, in a way, I was trying to offer, considering those cases.
I know. He's becoming a meta.
Sorry?
You're
What's
becoming a
happened
meta.
to you? You're talking about qualia again.
Okay.
The second time.
Yeah.
I recognize it. The example was I accept
It's
that.
the apocalypse.
It was the first one that I had. Okay.
This is the second time in one day.
No. Sorry. Sorry, no, qualia, no.
7 years.
Well, look, he can say, I was not about talking about quality, I was just talking about a red.
He's redness. Okay, other questions, remark, objection? Ben.
You had a question.
Drew,
I do, but that's okay. Go ahead.
No, Ben, go Ben.
So I'm looking at this slide, and this seems to be a snapshot of your proposal, the empiricist proposal you want to make. Just thumbnail sketch of the first slide.
Right.
So how is it empiricist? It seems to me you've taken logical notions and metalogical notions, and you've done some combinatorics. And in the process, not bad, but this is sort of, I'm not sure how this is empiricist. And in the process, you talk about the possibilities, which seems to me to say all possibilities. Whenever one invokes all possibilities, one must be implying a necessary claim. So I think you've done there's a non-empiricist slide, which is also making a necessary claim.
Well, I'm not sure.
How have I gone completely wrong here?
Well-
I sound crazy to myself, so maybe.
Yeah, no.
What-
Yeah, because I'm not talking about the necessities, right? So in fact, I don't think there are those necessities, right? What we have, as I said yesterday, right? The world of empiricism is a world of contingencies, right? And nothing's really necessary. What we get is relative necessities, right? If certain things are held fixed, then others, they will need to be the case. But those things that are held fixed don't need to be so, they could be other ones. And that's why things could have actually be different. Right? And the result is, I don't think I'm talking about necessities.
So when you say the possibility, because the words "the possibilities" are in the slide, there's no maximal set of possibilities, or there's more than one distinct maximal set of possibilities. There's no one maximal set of possibilities.
Yeah, so now,
So-
so I think the problem is you want to turn me into a metaphysician, right? You want me now you're gonna make a metaphysical theory about those things, and that's what the empiricists will be very skeptical, right? Why do I need such a theory, right? I'm making an argument about some local things and considering them, how they go, right? I don't know what the boundaries of those domains are, right? In fact, no one knows, right? We find out by investigating, by running into troubles, backtracking, fixing, and readjusting, right? So if you want me to give you a metaphysical theory about that, you're not gonna get one. Right?
So maybe even could I rephrase it as here are some possibilities instead of what are the possibilities?
I haven't talked about the possibilities, right? I don't think I have ever used that term. The,
Well, it's
No,
not-
there. That's what Ben is asking about.
I see this, the possibilities, okay, good.
But in fairness, that was,
It's not-
copying Restall's.
Yeah.
Ah,
that's
okay.
right,
This is
yeah.
a.
So maybe, good. So think of this as how,
Who's speaking here?
So,
Okay.
what are possibilities? That's what I meant, right? So, good, I'm glad you, because I don't believe that there are the possibilities.
Okay,
There
all
is a metaphysical category,
Okay,
right?
that's what confused.
Yeah, okay, sorry, no, it's a good point.
Well, you couldn't if because that would mean you believe that there are things that are only either complete or incomplete. Now you're back to being a classicist.
Exactly, yeah. Oh, classicists would say those things, right? But then, I will have questions whether these are all the possibilities. right? So that's,
So
yeah,
there's a mathematician, Martin Escardo, who does quite a bit of work in constructive mathematics. This is kind of what he's known for, homotopy type theory and so on. And he says, yes, but every mathematician either believes the law of the excluded middle or he doesn't. So in that sense, classical negation is necessary in the sense that we all wind up having to come down on either accepting it or rejecting it. So there is a necessity, there is a sense of necessity in that sense that it's somehow canonical. That's not the same as your meaning, necessity.
This is exactly my argument.
Yes.
So we need to decide
Yeah.
how we reason about necessity, if we want to reason about necessity.
Somehow it seems.
The alternative, we don't reason about necessity, so we don't need
Not
to
necessarily.
decide how to reason about necessity.
Yeah.
because
Not necessarily in the sense of universally applicable, but
Yeah.
necessary in the sense of being inevitable.
which is a different thing.
Yeah,
right?
yeah.
So, and.
But I think that was part of Emily's point.
Yeah.
Well, necessity
yeah.
may not mean universally applicable. It might mean something much more reasonable, which is that it can't not be there.
Right.
That's necessary.
Yeah, so then with because that's an interesting case, because there what's happening is we are considering something about practice, right? And what we do, that's its own constraints, right? We cannot both do and not do something at the same time, right? In doing something, we do not fail not to do it, right? So that there are constraints there. I mean, these are cases in which, classical logic seems to apply pretty well, right? So I don't deny classical logic applies in context. And I think this is one of those, right? So I don't see that as something
Classical
that,
logic apply most.
yeah,
It's
so,
certainly the logic that apply the most.
yeah, so,
Yes.
so that's perfectly compatible with what I'm saying. I don't think that I think he may say what he did because he said, look, I'm committed to, excluded middle being violated. But in a way, he's committed to them being violated in mathematics, right? Now, the question is not a mathematical question. Well, do mathematicians believe this or not? This is a sociological question. So it's a different context. Not surprisingly, the answer might be classical in that context, right? So I think that's exactly what a pluralist would acknowledge, right? Shifting context here. Right?
I mean, I think I only know 2 people who are not classical mathematicians. And I know lots of people who work in constructive mathematics. We know lots of people. There's one sitting right here.
So what are the two people that are not classical?
Well, you know one, Giovanni Sambin,
Okay, and the other?
and the other is Steve Vickers.
Yeah.
So these are people. who-
Yes, but Giovanni Sambin count for 9 now.
No, I mean, these are people, if you ask them about something that involves even impredicativity.
Yeah.
They will look at you and blink their eyes and say, I have no idea what you just said to me. They will act, they think, I mean, and I'm pretty convinced that Giovanni really does not understand you when you say something about all subsets of something or what.
Right. So yeah.
So I think so, but this is 2 people out of.
No, yeah. But there obviously there are more, right? Because you have Brouwer, you have Vio and one second.
In the afternoon, because
Yeah.
Sure, but sure.
No,
If you look,
no, sorry, if you're comparing Brouwer with Giovanni, you don't know Giovanni. Because Brouwer, if you were speaking with Brouwer, would say, yes, you are right. Your answer, I do not understand.
Right.
Yeah, you speak like, I
That's
don't
what I
understand.
It might be a more radical version,
No,
right?
all right.
Okay,
Yeah.
so, Weil, when he was writing Das Continuum, he was, sort of sensitive to predicativeness constraint. You have, Douglas Bridges, right? So there are people who will sort of develop interesting body of constructive mathematics, right? And for my purpose, that's enough, right? So they're exploring that domain.
Mhm.
It's working through, okay, how much mathematics can I recapture with how little, right? And
But that was Jose's point, right? So yeah, it is an interesting project to think about the minimal logic you need to carry out a program.
Yeah.
That's a mathematically interesting project.
I agree. Yeah, I agree. So it's a mathematical problem, but mine is not a mathematical problem. It's a philosophical.
No,
right?
Yeah.
So, and I don't disagree with it. You can certainly do that.
Yeah.
And build up.
That's a very good friend, by the way. I never remember his name. The logician that it is working in Ohio, that work on basic logic.
Oh, Newt Tennant.
Exactly.
Oh, yeah.
This is
Yeah. So, I think there are more than two, but
Yeah.
maybe not at the level of radical commitment that
that's
some
something
have.
a very nice.
I think that.
So why not to say?
No, I mean,
the logic?
Yeah.
when
Not to say that if you want necessarily, we really want a notion of necessity.
Yeah.
Why to say that minimal logic, whatever it would be, that we can discuss whether this is this one or this other or the other, but
Right.
whatever it may be, why not say that minimal logic is necessary?
Oh.
This is definition.
Because it may fail in some
Necessity is minimal
context.
logic.
It may fail in some context when you specify what the logic is.
So it's not minimal.
Right, so we may end up with no logic, right? You keep chopping out and you end up with nihilism.
Okay.
But I think it's better to be a pluralist that recognize context.
Yeah.
Well, it applies here, not elsewhere, but it applies here. That's something. Better than to say, no, I'm gonna be fully committed to something that it has to be so weak that, there's very little content.
Well, I also think there are metalogical principles, maybe they're model theoretic, that can lead you to think that certain logics are canonical. And classical first order logic is certainly one of those, because it's the only one that has compactness, which you may or may not care about, but it
Yeah.
seems like you should.
Yeah, compactness, Leibniz column.
Compactness is a pretty important, plus Lonheim-Skolem is first order logic,
Yeah.
right? This is Strom's theorem.
Yeah.
That's a pretty strong theorem that says there's something very special about, there's this sweet spot that says that I have this principle of compactness, which is a sort of completeness factor.
Yeah.
And the Lonheim-Skolem, which is saying that it's as strong as possible and as weak as possible.
Yeah.
And it's a sweet spot.
Yeah,
So
it is.
there's that. And then, and likewise for Hating's version of intuitionistic logic, there's a canonical sense in which it's the weakest possible structural logic. Right? So there are canonical choices of logics that I think I know that that's not the same as your necessity,
Yeah.
but I think that's also something interesting to think about. There's not simply this continuum or whatever of a bunch of different logics, and we just sort of look around for which ones apply.
Right.
But there's some that have external reasons for thinking that those matter more than others.
Right. No, I agree that they are, and in the case of first order logic, it's very interesting. But it's also very interesting when it fails, right?
Yeah.
Because suppose I'm
And
interested.
precisely how it fails. It's
Yeah.
actually quite an interesting.
Exactly, right? If I'm interested, look, I like categorical theories, right? And well, every model, of arithmetic is categorical. Well, not in first order logic, right? So, okay. So if I'm interested in capturing some structural features, well, then first order logic is too weak for that, right? So even there, it looks like even in the context of, classical mathematics, they violate these canonicisms for other reasons. So I think there is always a trade-off there. So it really depends.
Okay. It's necessary to close at certain point.
Thank you.